That's a personal thing.
But you can say yes.
You said that. Like, what would it be like?
It's hard.
Do I go to the restaurant? Thank
Okay, guys, today we're gonna go through worksheet 40. Just to make an announcement about tomorrow's test. You get to use your notes tomorrow. So open notes test tomorrow. You get to use your calculators. So, the test isn't any harder because it's open notes. I just want to hopefully help improve your grade and also give you a little bit of a safety net. But still want you guys to go through all the reviews. Yeah. Okay, so let's go through worksheet 3. And then if we have time, we'll circle back to the problem that we missed on worksheet 2. Okay. So worksheet 3 in your packet. Yeah, so let's see if we can go through all the problems here. So, all right, so we start off with just writing in log form. So not solving, just putting it into log form.
Log 3, 729 equals 6.
Log base through. Right, so the whole point of log form is to isolate the exponent to be by itself. Exponent form. So we just go in the other direction. This looks a little messy, but the base is that x plus y.
Or tests that we smart, is it just the packet and then?
Anything you want to use. Yeah. There's no phones. Okay, evaluate logarithm. So now we want to solve for x. So let's just go ahead and put an x there, get it into exponential form, and then see what you can do to solve for x. You can play with the bases. The 216 is something that you can represent in terms of 6. But notice that the 216 is in the denominator, 6 to the third is in the denominator. So if I want to bring that 6 up to match the bases, the exponent has to turn into a negative.
Okay, if there's a possibility to do like this 6 to the third, do we have to do that way, or can we just do the log thing?
Yeah, you can do it through
Either way.
log form, right?
Okay.
I still want to see your work.
Yeah.
To that point.
This touch will cut.
You can use your calculator, yeah. But I do want to see all your steps, like as if you did not have a calculator, so make sure you're showing all your work. You play with your calculator, 729 is 9 to the third power. Seven, there's a hidden base. .1, the same thing as 1/10. Get the bases to match, bring the exponent up. Okay, condensing. We want to eventually get everything as a single logarithm. Bring your coefficients up first. You see a minus in between the two logs, you can write it as a quotient of terms. Okay, number 9, bring the coefficient up as an exponent, and then you see a plus between two logs. You can go through product property there.
You want us to multiply it out with that?
Yep. Okay, so now going in the other direction, expanding the log expression. So we start off with a single log expression, but you see there's multiple terms. So for 10, we want to separate the 12 away from the B. And then for 11, you want to separate the C away from the D. So. Separate the 12 and the B to the fourth first, and then when that 4 comes down, it's just going to impact the second log term, not the first one. That exponent of 4 is only seeing the B, doesn't impact the 12. Okay, 11, we can use quotient property. C cubed and D can be separated using subtraction. And then once you separate, then the exponent can come down within that first term. Okay, any questions? First page? Let's move into solving exponential equations and log equations. Okay, so we're definitely free to involve logs because we don't solve for x, but anytime I see a chance for the bases to match, I find it easier to just play with the bases, get them to match, so I can just solve for x without having to go through logarithms. So here, the 25 and 5 can be adjusted in a way where they both can share the same base. The right side was good to go, just have to play with that 1 over 25. How can we get that 1 over 25 to be something that's 5 to a power? So you know, 1 over 25 is the same thing as 1 over 5 squared. And then continuing to work with that form, 1 over 5 squared is the same thing as 5 to the negative 2. And now we can drop the bases and just solve for x. Likewise, 256 can be written in the form of base 4. Yeah, 4 to the 4th, and now it's easy. Drop the bases, and then just focus on your exponent. And because these are exponential equations, there's no need to test and test your answers. Whatever you get for your answer is good to go. The only time you have to worry about extraneous solutions is the problem that has a log equation to begin with. Right, so problems like 14 and 15, then you have to, once you solve for x, you have to go back and test it against these highlighted terms that I have here. Make sure that it's not causing any of those expressions to be a negative. If it does, we have to remove it. Right, but no need to do that for 12 and 13. So 14, when you solve a log equation, you do eventually probably want to get it into exponential form, but first we have to use some properties to clean that left side up, right? So we have multiple log terms on the left side. Let's merge them together into one, condense into one log term. So quotient property. So now this is in log form. Let's get it into exponential form. There's a hidden base 10. So exponential form, base 10 raised to the first power equals the expression. And now you can just cross multiply and just focus on solving for x. 15, same idea. We do want to eventually get into exponential form, but first we have to merge the two terms together. I do see product property, but is there something that I can do before product property?
Divide by 3.
I'll divide by 3. Look at this first term here. Anything we can do to get this to a different form?
2 to the third.
Yeah, let's bring that up, right? Let's get it to be log A plus log B before we merge them together. That 3 is standing in the way. It's not quite as cleaned up as we would like. So let's bring that exponent to the top. Now we can merge the 2 cubed and the x together. Now we can get into exponential form. Oh, and then we should be testing, right? So sorry, I forgot to mention 1/3 was our answer for 14, but we got to double check. Is it going to cause any of these parentheses to produce a negative value? 1/3 plus 3 is positive. We're okay. 1/3 and for x, that's okay as well. So it passes all the tests. We keep it, right? So in order for it to pass the test, it's got to produce a positive value for every one of these highlighted terms. So here, the only x is here. 8, and for x, we're safe. No negatives in the log expression. Okay, 16. We would like to match the bases and can't get them canceled out, but that left side requires a little bit of cleanup. So here's something to remember. If I'm multiplying bases together with the same base, I can merge them together and just add the exponent. A to the m times a to the n equals a to the n plus n. So we can work on trying to get this to be a 1-to-1 relationship before we drop it to 5. So we have to merge the 3x minus 1 and the 2x minus 5 together first. Before we can drop the 5s. Again, 16 and 17 are exponential equations. No need to test your answers. Once you solve for x, you are done. Okay, 17. It would be nice if the bases can match, but it looks like 5 and 10 are not compatible, right? I can't bring 10 down easily in terms of the base 5. So it would be better if it was like 5 and 25, but 5 and 10 not going to quite work. So we have to involve logs here. So take log to both sides, bring those variable exponents down, and then you're just trying to work your way, trying to get x by itself. Okay, so there's a nice little relationship here, because once I take log of both sides and I can bring the exponents down, this ends up being log base 10 of 10, which is nice because log base 10 of 10 is 1, like natural log of b. If the base and values match, I can just let it drop out. If that's not the case, then you can plug in the calculator
But you'll be also convince yourself, oh, this is 1, so I can just drop that out. And makes it a little bit cleaner and faster to get x by itself. You can leave it like that, or you can write it as a decimal value. Okay, 18, 19, solving for natural log. It's just pretty much the same as 14 and 15. It's just log base e. But approach it with the same strategy. Get it down to 1 log expression before considering converting into exponential form to release that x.
For 17, did you like switch, like, if you put 2x on the other side and put 2 log 5 on the other side, like, to make a confusion?
So you see the terms that have logs,
Yeah.
that have x's in them.
Yeah.
So I just move them to the same side of the
You want them
equation.
to be together.
Yeah, I want the x terms together. I want the constants together so I can factor the x out and divide to the other side and divide the remaining terms to the other side. So for 18, there's not any properties that we can really use. Or 18, it's already natural log of a value equal to a number. We can just get it into, get that base e to show up for us, convert to the exponential form, and then algebraically just solve for x. Now this we do have to test because it's a natural log, but if I insert this value in for x, I'm safe. I'm not going to get a negative value, so we're safe. Okay, for 19, natural log of x minus natural log of 3 equals 0. You could set them equal to each other. You can use quotient property. Maybe a faster way to do this is just setting them equal to each other and then just drop the natural log. So we do have to test 3 in for my x value inside the natural log is safe. No negatives. Okay, 20 and 21. We want to solve for x. X is stuck in the exponent. So we'll use logs to bring that exponent down. Anytime I see base e, I just find it easier to involve natural log, because e and natural log have a way of cleaning each other up. So take the natural log of both sides. Once you're inside a log expression, your exponent is free to move. It says round to nearest hundredth, so I should have plugged this in the calculator here. 21, we do want to involve natural log, but there's a couple of things we should do first, right? Let's combine like terms, get the 1, the 7, and 3 to come together. before we call natural log of both sides. Okay, 22 through 25. It's graphing, so identify the transformations, sketch the graph with the three important information that you can put onto the graph: the vertical asymptote, order pair, two order pairs. And I want to talk about something here that if you're looking at your natural log or log graph and your table of values does not produce a order pair that has an x-intercept, you can always find the x-intercept by setting your equation equal to 0. Right? If you think about an x-intercept always has a y value of 0. So let's say y is equal to log base 4 of x plus 8 minus 6. If I want to find my x-intercept, just replace y with 0. And then just algebraically, like you've been doing before, just solve for x. Get that 6 to the other side, exponential form, solve for x. So your x-intercept doesn't show up easily for you, but you're just a log equation away from solving for x. So this is an example here. I want to solve for x.
Okay.
Mhm.
The thing I'm like most confused about in this unit is like how to find the actual coordinates, like.
Okay, yeah, so let me go
I need
over that
practice-
with
yeah,
you.
I need practice that.
Sure.
And also, what do you do if you like draw on a graph in pen and then you solve for the x-intercept and you realize it's kind of off track from how you drew it?
Just use pencil then.
Okay.
Yeah.
That's a stupid question. Right?
Let's go through, let's look at, okay, so let me go through the graphing properties. Okay, so the major properties that we really want to take advantage of is first, log base b of 0 is undefined, right? That's basically where your vertical asymptote exists. The second big property is log base b of 1 is always equal to what? 0, right? The reason why is b to the 0 power equals 1. And the third large big property is that if I can get the base and the value to match, that's equal to 1. Okay, so let's explore this here. So this is y equals log base 2 of x plus 8 minus 4. So let's just focus on the x plus 8, right? Because whatever causes this to be 0 is where your asymptote exists. So what's my vertical asymptote?
-8.
-8, right? Because -8 causes this expression to be 0, and log of 0 is where my vertical asymptote exists. So I know that at -8, there must be a vertical asymptote there. Okay, next up, I want to take advantage of this property here. So what can I choose for x that will cause this to turn into a 1? -7, right? -7 plus 8 is 1. Log of 1 is 0. 0 minus 4 is -4. So there's your second order pair. Or there's your first order pair, sorry. Third property here. What can I choose for x that will cause these to be the same value? -6, right? -6 plus 8 is 2. What's log base 2 of 2? 1, right? The bases match, it's equal to 1. So this is equal to 1. 1 minus 4 is -3.
Good question. So like it to test, like I know it's open note, but if it wasn't open note, would you give us those 3 formulas or would we have to memorize it?
Yeah, you would have to memorize that. I think these are really important ones that we have to just be able to know. And then
So, I'm probably doing stuff like this in calculus, so.
yeah, you're gonna have to need it next year as well. So if you think about it this way, right, this should make sense because b raised to what power is equal to 0. We know that there's nothing that I can raise a power and get 0. So this makes sense. This should make sense as well because b to the 0 power is equal to 1. If I get an exponential form, right? We know that's true. And then b to the first power is to the b. We know that's true as well. Now, so if you're stuck with this abstract form, think about the exponent form. I think we are more comfortable with exponent form. And if you feel comfortable with exponent form, just think about, okay, this is why the log form is also going to be true here as well. -7, -4. Okay, thanks. Okay, so our domain. What's our domain? Yeah. Your range is always going to be the same, never changes. Asymptote. And the x-intercept, notice x-intercept doesn't really show up for you. So just go back to your original equation, replace y with 0. And just solve for x.
Would it also be possible to just plug in like the log equation into our calculator and then find a y value that way?
You can, but I want to see your
But yeah.
work. Yeah.
Just like double check.
Oh, sorry. Double check. Yeah, that's fine. Well, it's a little bit harder to plug in the calculator because your calculator can't handle log base 2. It can only handle log base 10.
Oh, mine. Yes. 3 times. Sweet. Use the base.
I can change the base. Okay.
I was just.
Okay, good. Yeah. I don't graphing may not be able to do that, but I think yeah. Okay, try 23. See if you're able to identify your vertical asymptote, your property that'll get you to log of 1, and property that'll get you to log base b of b. Okay, if I insert 2 in for x, 2 minus 1 is 1. Log of 1 is 0. So 0 times -3 is still 0. And then 0 plus 1 is 1. Next up, if I want to target something that will cause these two to match, I can choose 4. 4 minus 1 is 3. Log base 3 of 3 is 1. So this whole thing is 1. 1 times -3 is -3. -3 plus 1 is -2.
Why is it 4 -2?
Because if I plug 4 in for x, what's 4 minus 1? 3. Log base 3 of 3 is what I'm targeting, right? You can finish up 24 and 25. And if I were to ask you what the transformations were, there's a couple of things going on, right? There's that negative, which is a standalone thing. That's reflection. The 3 is a vertical stretch. The 1 is a shift to the right. Translation to the right, 1 unit, and then that plus 1 is going to move 1 unit up. Everybody good with 23? Four. Vertical asymptote is at 0. Natural log of 1 is 0. And then natural log of e is equal to 1.
How do you get 1 over e?
Yeah, I use another property here, which is just saying that if I have log base b of 1 over b, that's equal to -1. But you don't really have to use that one. Just some additional
Is
property.
that like calculus?
No, it's just the same thing. It's the same idea here. If I have, because log base b of 1 over b is the same thing as b to the negative first power. If I bring that -1 down, log base b of b is equal to 1. So that's just another taking advantage of the exponent property here.
So you wouldn't mark off points if we don't get that.
No, it's fine.
The -3 rounded and like, is it like exact?
That's exact, because 1 over e, natural log of 1 over e is -1. -1 times 2 is -2. -2 minus 1 is -3.
So should we just multiply that number by the x value? Like how do we incorporate the stretch into this?
So the stretch is just built into the order pairs. Because when you multiply that value by 2, it's stretching it.
Okay, so you do multiply the x value by
Okay, so let's say I had 2 natural log of x minus 1. Right, so if I plug in E for x, I get 2 natural log of E minus 1.
Right,
What's natural log of E?
get one. there,
1.
so,
And then 1 times 2 is 2, and 2 minus 1 is 1.
One, okay.
So. I'm
So
not
if we
getting-
evaluate the expression, it'll.
Yeah, it'll just naturally, build in that stretch. You don't do, it's not doing anything extra, you're just trying to find the order pairing.
That makes sense.
Okay, any questions? Even though it's open notes, I think it's still a good idea to practice, make sure that you're comfortable, understanding how to get from one step to the next, because even if you have the key in front of you, if you don't know how to get from one step to the next, it's not going to help you on your test. But tomorrow morning, I will have a help session going over worksheet 4 at 7:30 over Teams as well as in the classroom. So I'll send out a reminder this afternoon. One more thing is that hopefully everyone does well on the test tomorrow, so that there won't be any need for recoveries. But if there is, and you still want to do a recovery because you scored under 75, then we can figure that out by next week. I should have it graded by Monday. If there's a need for recovery, I'll let you know. I'll put in the grade book so you can come in either Tuesday, Wednesday, or Thursday. Okay. Yeah. Okay, let me get back to you. Next year, I am teaching all the calculus classes. I'm teaching calculus A, B, and BC. It'll be a new challenge for me in the sense, I've taught BC before, but the challenge next year is I'm teaching 6 classes next year. So I won't have a planning period, but yeah, my challenge is going to be how can I get all the grades in a timely manner. So, I do have a summer packet for any students who are taking A, B, or BC next year. Now, this is non-mandatory. This is just voluntary. If you want to just review some of the logs, the pre-calc, the trig, you're welcome to pick one up. The key is attached. If you're taking AB, we're going to just spend a week doing some review. If you're taking BC, we're jumping directly into limits the first week. Yeah, feel free to pick one up. Oh, and then if you pick one up and if you misplace it, it'll be on my website for under AB and the BC homepage, or can't find it or something misplaced it, just you can also email me. I'll be able to get back to you. Okay. But yeah, thanks for a great year, and I hope to see many of you guys next year again for each ABC. Okay, you go get your phones. Help session tomorrow. Let me know if you have any questions.
And I don't know my thoughts.
I think like logs that's there, and like these were one big track. But those are still at test.
Yeah, so this is just some additional properties here. If I have a base race.
I asked a dumb question, and this is one of the dumbest questions. Yeah, I definitely need help with the tracker.
So the bases match,
No,
exponent form.
I can draw it.
Cancel that out. Same thing here, if I have log base, the equal to b. That's also equal to x. So basically, logs and exponents are just going to cancel each other out, depending on which one you're in.
Mr. I go to the, can you explain this one? How it, you like, what's not the order?
So here, I just convert to exponential form. So if I have log base with x over 3 equal to 0, b base is in power of b.
I don't understand on that one lot of things. We have to 3 hours.
I don't get how you got, like, how you grabbed it. Like when you put like one.
Oh, you need a circle.
You get to.
So that's just another property. here's the, I didn't really go over it, but, so I have log base b of 1 over b. That should be equal to -1. And the reason why is because this is the same thing as
That's bad.
e to the negative 1.
Yeah.
And that -1 can come down.
Okay.
But
This goes away. It's just like that's fine. But you don't have to use this one there. But some of the additional easy ones that can help you line up your graph a little more accurately. That's all. Oh, right. So E is around 2.7. So 1 over 2.7 is really
Oh, so then you like cross out 5. Oh, the answer's 2. For this one, the answer.
It's a space. Here it's in that. All that.
And then like this makes it 17.
Like what is happening?
And then how do you do
And
this?
like 89.
So that's the log of E.
Like.
This is log. So the exponent.
I hate.
What's that?
It's just like, I'm trying to find out myself.
The reason why this is log is.
I was like, give me like, was.
Fine.
But I didn't say, GBC and like I would feel.
Like, really?
I think so. So like I think that's the do it now. So this can be back. So my next question will work a little bit.
Oh, because I didn't say.
Order pair.
That's fine.
Well, you know, break out that is at 0, right? So 0. I'm gonna choose 1. So this is 0. 0 times 2 is 0. 0 minus 1 is 1. Next one is obviously 2. Because natural log because the same thing as that should be enough to.
You're doing the AC.
That's just.
From now.
Because we know these log base B of B is equal to therefore. And then 1 times 2 is 2.
Wait, so I guess 16.
Natural length is the same thing as. It's just a shorthand way of writing. Right. Yeah, it's that one.
Thank you.
I was gonna say maybe a DC because I didn't realize you were teaching BC like next year. So there's sort of an option like maybe switching into it.
Connor, I think,
You wanna do this?
I think AD will challenge me. Yeah, these guys. I mean, do you, I mean, what's your reasoning?
I don't know, I feel like I can, about ADHD is contained medication. Now I feel like I can focus a lot more.
She's come to my surgery.
I
I know. You have Spanish first period? And then they went.
think the fear is that,
They went to English together.
that it's hard to slow down for students. Like AB is gonna go faster than it's not. BC is just faster than that.
That's you not stay dating.
So, yeah, and I fear. If you
Go home.
struggle a little bit, then to catch up. But that's just my suggestion.
Okay.
You put in the work.
Oh, wait, no, he got spurs on his face. He knows he
I guess
is.
I'll be all right.
Four next week.
That's a lot.
Don't worry, I know. I know you.
BC.
Oh.
So AB, I feel like some students can get away with it. Hey, really good patient class, but BC, you have to put in a lot of work outside. I gotta come back. So,
How much work do you do?
AB,
It's bad. I'm getting too much this right now.
30 minutes.
Like, I have the choice,
But, you know, usually students put up work on the day before test. Hours. Have a great day, guys. See you tomorrow.
You're gonna pull up?
Yeah.
So I'm going to make the next, what do you actually do like over the summer to like prepare? So I heard you might need more a little bit, but is there anything you recommend?
So, definitely pick up the packet. Okay. And then if you feel like you have some additional time, I have videos recorded for all my AB classes. So if you want to just watch the videos for limits unit and just see how much you can pick up. And then if you want to, I've recorded every day of AB. So if you just want to just get familiar with AB and see how far you can get, I think that'll be good. But yeah, I think just because we're having to move at such a fast pace. And then all the students who've already taken AB, you know,
I thank you.
you're gonna feel like they're not really trying because they've seen the whole first semester already. But yeah, I would just say, you know, work through the packets, work through chapter 1 and chapter 2 if possible. If you can do more than that, great. But, you know, watch the videos. I think that will kind of give you an idea, kind of give you a head start.
Okay.
Mhm. Bye.
What did you do today?